All right, folks, welcome to Yak Math Videos for your Calculus Chapter 4 Quiz Number 1 review video. Your quiz is this upcoming Wednesday. Folks, we are brought to you by Chinatown Coffee Espresso Ruby Tuesday. Crushed Red here in Edwardsville and Crazy Bulls and Wraps. Unfortunately, Adidas has pulled their sponsorships. Yes, evidently, affordable shoes or mediocre shoes at affordable price was not the agreed upon slogan. So ultra running shoes are now in as our new sponsor. Be fast like Mr. Yak in your ultra running shoes. Anyway, folks, numbers 1 through 4, find the local max and min values of the function on the given interval. All about the first derivative. All right, so you set the first derivative equal to 0. Remember, if the derivative is equal to 0, then the slope at that point is 0. So something's happening potentially. We got an increase going from increasing to decreasing, or vice versa. Anyway, number 1 is not fantastic because your two critical values are irrational. Root 22 over 3 or negative root 22 over 3. I am sorry for that. So it's roughly negative 1.56, positive 1.56. Anyway, because this graph, we don't necessarily, I mean, we know the shape, you know, it's an odd degree. The coefficient, leading coefficient is negative, so you can kind of sketch. But the minimum value on that interval might be that first number allowed, -2. The maximum might be -2, or the minimum might be 6, or the maximum might be 6. So anyway, we got to test those endpoints there of -2 and +6. So you plug that, you always plug it into the original there. Always plug it into the original to figure out min and maxes. Okay, so plug -2 in for x, you get -13. Plug about -1.56 in, that's what you get. Plug positive 1.56 in, plug 6 in. So notice -509 is definitely the lowest value, and 29.93 is the highest value. So those represent your mins and your maxes, which I wrote there. Okay, folks, some of these questions aren't answered totally, all right? Some of these are a little bit harder. I did just make your quiz, and it is in lovely, lovely order. You get relatively nice answers. Nothing like this. This quiz review has some more challenging answers. Anyway, take the derivative, all right? So let's divide everything by 3, then you get some nice factors. X equals 1, x equals 3. Now notice why I got rid of 1, because 1 is outside that interval. I'm just looking from 2 to 4. So I'm going to keep 2, I'm going to keep 4, and I'm also going to use the critical value I found of 3. So be like, laid in, plug it in, plug it in. So the original f of x, and my max would be at 4, 5, and my min would be at 3, 1. So that is a relatively lovely question. Folks, here we are going to write it as, I did not rewrite it, but you know that 1 minus x, the square root of that is 1 minus x to the 1/2 power. I use the product rule here, so derivative of the first, derivative of x is just 1, times the second, we'll call it term there, plus the first, times the derivative of the second. 1/2 power comes on down, 1 minus x to the 1 power less, negative 1/2. Then I take the derivative of negative x, which is -1. I need to clean it up a little bit. -1 times x times 1/2 would make it a minus 1/2 x. Then we're right there with the, really, I'm just going to rewrite it here as 2 times the square root of 1 minus x on the bottom. All right, set that equal to 0, and then what I did is I just moved this function over to the other side, add it to the other side. All right, do a little cross multiply, and you get x is 2/3. Now, x equals 1 is also a critical value because it makes the derivative undefined. Remember, that's a critical value. If the derivative is undefined at that value, it is a critical value. Now, notice how 1 is also like an endpoint of that interval, so we're going to use it no matter what. So 2/3 and 1, and then -1 right here is another critical value. Anyway, plug all those in, and that's what we get. Negative root 2 is my smallest value, and then 2/3 times the square root of 1 over 3 is the maximum value, which I wrote there. Again, you're going to get more pleasant answers on your quiz. Okay? This next one here is definitely fair game. Take the derivative. It's 1 minus. Why is it minus? Because the derivative of cosine x is negative sine x. So we get a minus there. Sine 2 sine of x. Move the 2 sine of x over. You get sine x is 1/2. So you got to know, first off, sine x is positive in the first and second quadrants. You know, you have to know the pi 6, pi thirds, pi fourths, pi halves. Again, if you go in radian mode, you can check it on your calc. But sine of pi 6 and sine of 5 pi 6 will give you a value of 1/2. All right, so pi 6 and 5 pi 6 are critical values. Where did I write this? Also, right up here, I got to type in negative pi and pi. Get some weird looking answers there, but remember pi is, you know, roughly 3.14. Anyway, the local min is negative pi, comma negative pi minus 2. That's about negative 1.54. And my local max is at pi 6, comma pi 6 plus root 3, which I believe is a little bit more than 2. All right. Anyway, we're going to talk about this a lot on Tuesday. Here is simply just find the critical values. Again, the critical value, the derivative, when you plug it in, you get 0 when you evaluate the derivative, or the derivative is undefined. Low d high minus high d low, the quotient rule there. Okay. That looks good. Clean it up as such. Now, when you set, so first off, the first critical value is you set the denominator equal to 0. That would make the derivative undefined. That's how I get plus or minus root 5. And the second one is you would set the top equal to 0. That's how you get a rational function to be 0. You need the numerator to be 0. Multiply everything by a negative 1. Again, I'm not looking for when this is increasing or decreasing, so I don't have to worry about plugging it in to the correct numerator up there. The first one, then I get those two critical values of negative 1 and negative 5. Here, folks, take the derivative, and your critical value is very simply 1. All right. Find all values of C that satisfy the conclusion of Rolle's theorem on the given interval. Rolle's theorem says, so this graph has got to be continuous on the interval 0 to 36, and got to be able to take its derivative. And f of b is equal to f of a. F of a is equal to f of b. So f of 0 must equal f of 36, which it does. They both equal 0. So simply set that derivative equal to 0. Guys, it's the mean value theorem, just with if f of b is equal to f of a, then this top thing is 0. All right, so the mean value theorem, Rolle's theorem, you know, they go together really nicely. So find the derivative. Again, square root of x is x to the 1/2. Bring down the 1/2, multiply it by 3. That's how you get 3 halves. X to the negative 1/2 minus 1/2. All right, so I'm going to put the x to the negative 1/2 in the denominator. And instead of writing the square root of x, I'm going to write the square root of c because we're finding a value c. All right, move the 1/2 over. Cross multiply. C equals 9. 9 is between 0 and 36. That works. Same thing here, folks. Just make sure that f of negative 6 is equal to f of negative 2. And we get 41 and 41. Very good. Because you'd have 41 minus 41, you'd get 0. So the slope there would be 0. That means simply set your derivative right there. And we're going to I'm just plugging c in for x. Set it equal to 0. And you get c equals negative 4, which fits perfectly in that interval. All right, so those questions shouldn't be that bad. Now, I believe we have a mean value theorem here. So we're going to say f prime of c is supposed to be equal to f of b minus f of a over b minus a. All right, you got to have that down. That, again, is just like the last one. This time, f of b minus f of a isn't going to be 0. All right, so I need to find f of b and f of a. F of b would be f of 7. B is the bigger number there. You get 400. F of negative 1, that would be your a value. You get 0. Well, 400 minus 0 is just 400. And then b minus a, 7 minus a negative 1 is 8. So that's 50. And you need to set it equal to the derivative. Again, instead of writing x, I'm going to write c. That's the derivative. Move 50 over. It does factor nicely. Again, the quadratic form is there to use. Negative 5, folks, would be an issue, right? Why is negative 5 an issue? Because it is not in that interval. So my fault's there. Negative 5 would be critical value in, sorry, negative 5 is not in that interval there. All right, no big deal. 11 over 3 is in that interval. So we're going to use 11 over 3. We're not going to use negative 5 again in that interval, negative 1 to 7. All right, find where each function is increasing or decreasing. That's just the first derivative. And then we go from there. Take the first derivative, set it equal to 0. I get a critical value of 9 over 2. So I have my two intervals, negative infinity to 9 over 2, 9 over 2 to infinity. So I need to see what f prime of x is doing. So I'm going to use 4. I'm going to plug 4 in for x right here, and I get a negative. If my derivative is negative on that interval, then f of x is decreasing. Okay? 5 would be lovely, or I could also plugged in 0, right? 0 would have been a better one. Anytime you can use 0 as a test value, do it. Doesn't matter, you would still get a negative. If I plug 5 in here, I'm going to get 10 minus 9, which is positive. If f prime of x is positive on that interval, then f of x is increasing. All right? Take a look here, folks. Find the derivative. I divided everything by 2. Then it does factor pretty nicely by grouping there, or just regular factoring, sorry. 2/3 and negative 2 are your two critical values. So I have 3 intervals, negative 8 to negative 2, negative 2 to 2/3, 2/3 to infinity. All right. So negative infinity to negative 2, plug in at negative 3 right there. You would have a negative times a negative, which is a positive. F of x is increasing. Negative 2 to 2/3, plug in 0 for sure. Well, if you plug in 0, you're just going to get negative 8 or negative 4 there, or a negative times a positive, which is a negative. So it's decreasing on the interval. And 2/3 to infinity, let's plug in 1. You get a positive, a positive. A positive times a positive is a positive. So it's increasing. F of x is increasing on 2 intervals and decreasing on 1 of them. All right, on 11 here, folks, you have a rational function. So you're going to have, when I take the derivative, again, low d high minus high d low, cleans up relatively right there. Okay, so this one's not fantastic, and I'm not going to finish all of these because you get a terrible answer. So just know how to do this. Now, negative 4 would count as a critical value. That's why it says that. You would have to count negative 4 as a critical value because it makes your derivative undefined at that point. And then those other two are bad, so we're just going to stop there on Tuesday. All right? The ones you get on your quiz, come out nicely, like a 9 and 10. So that is my fault. All right, again, we're going to do the same kind of thing here. This is the big daddy problem here. Everything involved. We're going to go through most of these. Again, some of these are not swell to look at, but you'll get the point. Find the intervals of increase, decrease. Find the min and max values. Find the intervals of concavity and any inflection points. Okay, this is worth like 6.5 or 7 points. You're going to have 2 of these on your quiz. First off, find the first derivative. Okay, set it equal to 0. You have 2 critical values of 0 and 2. So right up here, 2 critical values of 0 and 2. So you got your 3 different intervals then, negative infinity to 0, 0 to 2, 2 to infinity. And then plug in some points. You can't use 0 as a test point, bummer. I'm going to plug in negative 1 for the first interval. I would have a negative times a negative, which is a positive. I'm going to plug in 1 in my second interval. I would have a positive times a negative, which gives you a negative. And finally, like plug in 3, positive times positive gives you a positive. So f of x is increasing on 2 intervals, and just decreasing on 1.